In this video, we will talk about compound dependent probability. Compound probability is when two or more events occur and we multiply. And dependent probability is when the probability of one event does affect the probability of the next event. And this is without replacement. Be sure you're taking notes throughout this video. A box contains a penny, a nickel, and a dime. Find the probability of choosing a dime first and then, without replacing the dime, choosing a penny. So when I look at the probability of my first event, the probability of the dime, first I want to look at I have 1, 2, 3 coins, and only one of them is a dime. Now, I started with 3 coins. I took that dime out and I didn't put it back. So I'm left with 2 coins. So now when I look at the probability of the penny, I only have 2 coins left, so that's going to be my new denominator. And only one of those coins is a penny. Now that I have the probability of both the dime and the penny, I'm ready to multiply. So we're going to look at the probability of the dime and then the penny. So the dime, the probability is 1/3. And I'm going to multiply it by the probability of the penny, which was 1/2. And I'm going to get an answer that is 1/6. So the probability of choosing a dime, not replacing it, and pulling a penny is 1/6. This is a dependent probability problem because we are not replacing, aka putting back that dime. Now let's look at a second example. A store sells a box of highlighters that contains 4 yellow, 3 blue, 2 pink, and 1 green highlighters. What is the probability of randomly picking a blue highlighter, keeping it out, and then randomly picking another blue highlighter from the box? So let's start by looking at the probability of that first blue. If I look, I have a total of 10 highlighters in that box. And 1, 2, 3 of them are blue. So I have 3 blue highlighters in the box. Now, things get a little weird when I have to look at the probability of the second blue. Because I took that blue out, it's no longer in the box. I'm only left with 9 highlighters and only 2 blue. So the probability of us choosing a blue the second time will be 2 out of 9. Now that I have the probability of the first blue, which was 3 out of 10, and the probability of the second blue without replacement is 2 out of 9, I now can determine the probability of this happening. So 2 times 3 is 6, and 10 times 9 is 90, which simplifies down to 1 out of 15. So this is a dependent probability because we are not replacing, aka not putting back that highlighter. Make sure you took notes. You can pause, rewind, and rewatch this video as many times as you need.